Okay, so moving on to, um, I'm not sure what number this is, but it's the economics problems. It's the first one. I'm assuming it's probably problem 7. Problem 7. Let's read through it. Find the consumer and producer surpluses by using the demand and supply functions, where P is the price in dollars and X is the number of units in millions. All right, so we got to find the consumer surplus and the producer surplus. I, I'm not going to explain all the economics because that would take a ton of time. And hopefully you've taken economics and some of this will be familiar. But if not, I'll explain enough so you kind of get an idea of what's going on. And it has been some time since I've worked these economics problems, so I might not be as fluid in the process as I might otherwise be. So bear with me as I kind of work through this. But here's what we're going to do. First, let me show you what a consumer surplus is and what the producer surplus is and how we calculate them in general. So for a second, forget all this. Just forget all those numbers, forget this specific problem. I'm talking in general. Here's how you do this. What you do is you take your demand function, and remember your demand function, let me kind of sketch this out. Again, this is just in general, has nothing to do with this specific problem. But your demand function looks like this. And your supply function, do a different color, looks like this. Where this axis is your price and this axis is the quantity demanded. Where they intersect, let me do a different color on that. Where they intersect is your equilibrium. That is your equilibrium. So let me go ahead and put a line through that. And your consumer surplus is represented by this area right there. That area represents your consumer surplus. And just real brief, that represents the amount of money the consumers are saving by paying the equilibrium price. Because we had consumers that were willing to pay this price up here. So the equilibrium price is below what they were willing to pay. So they're actually going to be saving this amount of money. All these consumers that were willing to pay more, they're going to be saving that amount of money by paying the equilibrium price. That's your consumer surplus. Your producer surplus is represented by, let's do this color, this area right down here. This area right here, that purple, that's your producer surplus. It's your producer surplus right there. And we got to calculate these areas. And here's how you do it. And of course, we're going to be using calculus to do it, obviously. Let's focus on the consumer surplus, this area. What I could do is I could take the integral of this function and I could find this area below the function all the way to the equilibrium price. I could find what that area is under that curve. And I could subtract out this area right here. See that? If I find the area, let me just say that again so it's really clear. If I find the area under my demand curve right there, and I subtract out this area right here, I will be left with the area I'm looking for, the consumer surplus. So that's what I'm going to do. I'm going to find out what is this whole area right here. And then by taking the integral, of course, and then I'm going to subtract out this area right here. And this area right here is just your equilibrium price right there. It's your equilibrium price times your equilibrium quantity. That's what that area is. It's just a rectangle. It's your equilibrium price times your equilibrium quantity. So when I subtract out that, I'm just subtracting out that rectangle. And that'll leave me my consumer surplus. So this all goes back to economics. I hate to fly through it like that, but hopefully you've taken economics at some point in the past. And hopefully you've done it recently, so maybe some of these economics concepts are familiar to you. But I'm going to start out by finding the consumer surplus, that area right there. So let's go ahead and do it. So let's see. I'm trying to think what's the quickest way to do this. Yeah. Well, first thing you got to do is you got to find this. You have to find out this equilibrium. The equilibrium is where these two functions intersect. So that's my first step. I've got to set both functions equal to each other. So I have to go 290 minus x equals 140 plus x. That's how you find where two functions intersect. You set them equal to each other. And then you solve it. So I'm not going to walk through how to solve that. Just an algebra problem. I get the x all by itself. So I'm going to have 2x equals 150 and x equals 75. All right. So they intersect where x equals 75. And I got that by solving that equation. Got the x over here, got the number over there. It was x equals 75. So that tells me the x on this point of intersection. The x is 75. Let me do my blue. The x is 75. But I need the y that's associated with it. So the x is 75. That's what I just found. But that's the equilibrium quantity. Down here, that's your equilibrium quantity. I also need the equilibrium price. So to get that, what I do is I take the 75 and I plug it into either one of these functions. It doesn't matter which. You get the same answer. I'll just put it into this function. 140 plus 75 is 215. So your equilibrium price is 215. So that point of intersection is 75, 215. Okay? 75, 215. That's your equilibrium. 75 is your equilibrium quantity. 215 is your equilibrium price. And now I can find this area right here. That area under my demand curve. That's the first step. I'm going to find that whole area under the demand curve from 0 to 75. So that's the whole integrating and finding the definite integral like we've been doing in the problems before this. So I'm just going to focus on 290 minus x. That's my demand curve. And I'm going to take the integral of that, which is going to be 290x minus, I'm just using the power property. The integral of 290 is 290x. The integral of x, if you don't see an exponent to 1, I add a 1 to that 1. This is the power property for integration. It's going to be x squared divided by 2. That's the integral of my demand function, and I need to evaluate it over this interval from 0 to 75. So 75 is my upper, 0 is my lower limit. And just like I did in the last few problems. To do this definite integral, the first thing I do is I put a 75 into here and here. Let me do that right now. It's going to be 290 times 75 minus 75 squared divided by 2. And then you subtract. And then you put a 0 into this. Well, if I put a 0 here, 290 times 0 is 0. 0 squared is 0, divided by 2 is 0. So if I put a 0 into this thing, it's just 0. So I'm subtracting a 0, which does nothing at all. I don't even have to write it. So if I put this into my calculator, it will tell me what this area is underneath my demand curve. That right there. I'm going to go and do that. I'm going to pull up my calculator. I'm going to carefully type that in because I don't want to make a careless mistake on a problem that has this many steps. Minus 75 squared. I'm going to divide it by 2. What's that? 18,9,375. Let me make sure. 18,9,375. Hold on one second. Oh. And I'm getting, you might want to plug it in there to your calculator also to make sure you get the same answer I'm getting here. I am getting, when I plug that in, 18,937.5. That's the area under my demand curve from here to here. But that's not your answer because your consumer surplus is this. It's not this. That's too much. I need to subtract out this. Okay? See what I did? I took this whole thing right here. That's the area I just found. And I'm going to subtract out this. And when I do that, I'll be left with my consumer surplus. So I need to find out what's the area of this rectangle. Well, that rectangle has a height of 215 because right there, that's your equilibrium price, 215. So it has a height of 215. It has a length of 75. So 75 times 215 is the area of that rectangle. It's just the length times the width. 75 times 215. And that's going to be 16,125. All right, that's the area of that rectangle. Now, if I take this and subtract this, that should be my consumer surplus. Let me go ahead and do that real quick. I'm going to go 18,937.5, and I'm going to subtract 16,125. Now I'm going to double check to make sure I didn't make any careless mistakes. So give me just a second. Yeah, that should be it. So the answer for your consumer surplus is going to be 2,812.5. That's going to be your consumer surplus. And that's just half. Obviously, that's just half the work because we also have to find the producer surplus. All right. So I'm going to erase all of that work that I used to find the consumer surplus. So I have room to find the producer surplus. Let's see. Here, that's good. The graph's still good. It's going to be the kind of the same process. What I'm going to do is first I'm going to take my supply. Let me think of the best way to do this. Hold on one second. Yeah, let's do that. You know, I could do the same thing I just did with all of the integration and then subtract out, let's see. Well, actually, you don't have to do the same thing here. There's so many ways to go about this. Let me show you something. The quickest way to find this producer surplus. The quickest way to do it is going to be, and let me make sure this works. I've got 75 here, 215. I'm just checking a few things, so give me just 1 second. If I go 75 times 215, and that's going to be 75 times 215 divided by 2. 125 divided by 2. 8,062. Give me just 1 second. I'm trying to think about the best way to show you how to do the producer surplus. You could just follow the same steps, but I'm thinking there's a much quicker way to do it. So hold on just 1 second. Okay, so I think I'll just go ahead and do the calculus. There's quick ways to do this because you have triangles, and you don't have to do the calculus. But since we're in a calculus class, let's just stick with the calculus. So we'll do this using calculus. And it's going to be the same sort of process that I used to find the consumer surplus. To find the producer surplus, I'm first going to find the integral of this, which is going to be 140x plus, and then I'm going to go x squared divided by 2. That's the integral of this thing right here. And I'm going to evaluate it over my interval, which goes from 0 to 75. Now, when I do that, let's see what I'm finding. I'm going from this interval, and I'm finding the area under my supply curve. So I'm actually going to be finding this area right here, the area under my supply curve. That's what that's going to give me. But notice I need this area. So when I do that, that's not the area I'll be getting. I'll be getting this area. So we'll have to do a few more things to actually get that purple area. But we have to go through this step first. And to do that, I'm going to take this 75 and I'm going to plug it in here and here. So it's going to be 140 times 75 plus 75 squared divided by 2. Then I'm going to subtract. And I'm going to put my lower limit in, 0 and 0. Well, that's just 0. 140 times 0 is 0. 0 squared divided by 2, that's 0. So this whole thing is 0. So I'm going to be subtracting out a 0, which means I don't even have to write it. So this area underneath my supply function is going to be this right here. So I'm going to go to my calculator, and I'm going to carefully type that in. 140 times 75 plus 75 let's see, squared divided by 2. You might want to type that in too. Make sure you get this answer I'm writing down. That's going to be 13,312.5. That's the area under your supply function. Is 13,312.5. But that's not what we want. We don't want the area under the supply function. We want this purple area. So what I have to do is I have to take that rectangle we talked about when we were finding consumer surplus. I got to take that rectangle. I got to take its area, that whole area, and I got to subtract out the area I just found. And when I do that, I'll be left with this purple area. So that's what I'm going to do. I have no idea what the area of that rectangle was, so let's calculate that again. It had a height of 215 and it had a length of 75, and I get that from these two numbers. And that's how you find the area of a rectangle. Length times width. So it's going to be 215 times 75. Let me put that in my calculator. Which is going to be 16,125. And I'm going to take that area of the rectangle and I'm going to subtract out the area that I just found. And when I do that, let's see what I get. 16,125 minus 13,312.5. I'm going to get I'm going to get the same thing. 2812.5. That's also going to be your consumer surplus. 2812.5. And that's the answer to those two problems. I'm going to end the video here because it's getting kind of long and I'm thinking it's going to take a while to upload, and I'll work the other ones here in just a minute.